Hello and welcome to this wonderful presentation. Today we have Dr. Giuseppe Futia. He is an independent AI consultant with a specialization in knowledge graphs, graph neural networks, and language models, small and large. No size is too great. He is a published author, and today he's going to give us a wonderful presentation as part of the Human and AI Symposium on bridging AI and human cognition. So, welcome to have you.
Thank you. Thank you very much for the introduction, Joachim. And today I will try to provide some reflections about this idea of bridging AI with human cognition. I will start the presentation by defining some abilities that are usually related to human cognition and that sometimes we attribute to large language models. Then we will try to understand how actually far LLMs are from achieving these specific abilities. Then I will try to provide you some insights on how we can leverage graph technologies in all their forms, right? Knowledge graphs, graph-based algorithms, graph machine learning, and so on, in order to reduce this gap, right, between these human abilities and the capacities of LLMs. And finally, I will provide some final thoughts on human intelligence. So I decided to consider these four different perspectives related to the human cognition. So these perspectives include discovering, so basically the ability to gather new information and identify potential options. The reasoning itself that actually characterize the faculty to analyze and evaluate information to make decisions. I will consider the planning ability, so basically the skill to create a structured strategy or roadmap to achieve a specific goal. And finally, I will discuss this idea of execution, so the capability to implement plans and then take actions to reach the desired outcome. So I will focus on the inner working of LLMs, and I will also provide you some opinions of researchers and technologies to understand the gap, right, that exists between these human cognition abilities and the capacities of LLMs, right? So to understand his behavior and how far they are from these abilities. So let's start with these questions. Are LLMs able to discover new things? And I would like to start with these statements and sentences by Edward Frankel, which is a mathematician from Berkeley, which consider his own activity, his own mathematical research as a never linear process, right? So in his research activity, basically it's never like give me more data, giving me more data, giving me more data, and boom, the glass is full, and then I come up with a discovery. According to this idea, discovery is always felt as a leap, right, as a jump. So the idea is to understand, can LLMs be jumpers? And he provides a very interesting, in my opinion, example in the history of mathematics. So basically, his question is, could an LLM ever come up with the complex numbers idea if, according to all the previous accumulated knowledge, you cannot have a square root of -1? This is, I think, a crucial example, because before this discovery, before this jump, this leap, basically it was really difficult to reach this this idea considering the previous knowledge, right? So we have to think about if an LLM is able to reach this specific jump, to reach this specific result. And I would like also to add some other ideas, right? In this case, from Jeremy Howard, which is the co-founder of FastAI, which is an education provider that focuses on making deep learning more accessible. And FastAI is also one of the most used deep learning library. And basically, Jeremy Howard says, absolutely any time I try to explore something, even slightly against commonly accepted beliefs, LLMs always just rehash the commonly accepted beliefs. So this is important, right? Because if we consider the example of complex numbers, sometimes LLMs give the mistaken impression that there is nothing to explore. On the other, what seems new sometimes coming from the LLMs actually is just a rehashing of common beliefs of already existing information. So I think that these quotes can provide you an idea of to respond to the answer. So basically, our LLMs are able to discover new things. Let's continue with our questions in order to clarify other type of behaviors of LLMs. So another interesting question is, are LLMs able to reason about facts? And again, Jeremy Howard helped us to understand this idea, because it says it's not helpful to just say that LLMs can't reason, since clearly they do some things which human would use reasoning for. But an interesting point is that LLMs largely work by fuzzily finding and interpolating concepts found in their training sets. So the key idea is that rather than understanding and reasoning in the way humans do, actually LLMs use statistical patterns and relationships with the massive amounts of data they have been trained on in order to produce coherent and contextually appropriate text. So basically, this involves a matching process where some pieces of information are blending together in order to create a plausible output. And regarding this idea of detecting statistical patterns, there is an interesting point that is highlighted by Vedant Misra, which is an IE researcher at DeepMind that work on Gemini, Minerva, and other large language models, that states that any sufficiently advanced pattern matching is indistinguishable from reasoning. So this is important because this is the trick, this is the bias that usually we have when we interact with a large language model. So basically, we are not able to distinguish an advanced pattern matching from actually a real concrete reasoning. And if you are interested in reasoning, I suggest you to read these very useful papers that is called Alice in Wonderland, Simple Tasks Showing Complete Reasoning Breakdown in State-of-the-Art LLMs. And in this paper, the researchers provide a lot of pure reasoning questions to the LLMs, and they noticed that they failed many times, right? So basically, they reach a very low accuracy compared to the benchmark that you usually heard about the capacity of LLMs. And this is a typical pure question reasoning, right? So Alice has N brothers, and she also has N sisters. How many sisters does Alice's brother have? And they noticed that at the time in which they made the experiments, the LLMs in some way forgets that Alice should be included among the sisters, right? I would like to continue with another questions, right? That it's relevant to understanding the behavior of LLMs compared to the human cognition. And the question is, are LLMs capable to plan a strategy? I would like to show you this example from Claude. So basically, it's the Claude is the flag LLM, so the flag project of Anthropic. That's in many benchmarks, it was able to overcome also the flag project of OpenAI, so basically ChatGPT 4.0. And the question in this case is, a farmer stands at the side of a river with a ship. There is a boat with enough room for one person and one animal. How can the farmer get himself and the sheep to the other side of the river using the boat in the smallest number of trips? And here I have highlighted the counting, right, of the trips. And this is weird, right? Because it says that firstly, the farmer goes with the sheep, so one trip, then the farmer returns, 2 trips, second trips, and the farmer crossed the river alone, third trips, right? So this is interesting. This is interesting, the way in which the LLM reasons about this problem that apparently seems quite simple. And providing this example, Jan LeCun, which is probably one of the most important researcher in AI, which is also the chief AI scientist at Meta, taking this example, he makes a joke, he makes a boutade, right? Because it's French. LLMs can plan, huh? We should think about that. And according to LeCun, the main issue is that LLMs have no common sense, no understanding of the world, and no ability to plan. So another user in Twitter provided another example. And this user actually tried to make the same question in terms of reasoning, which is rephrased in terms of the key agents that actually operate in these sensors. So basically, the person and the object mentioned here do not match the classic riddle, including farmer, sheep, cabbage, or wolf, right? Because this example is probably overrepresented in the training data. So in this case, if we have a look at the results of the reasoning, it seems to work, right? But this example, I think that show us that, I mean, LLMs are in many cases considered as stochastic parrots. But in the new papers, the authors mentions that LLMs are like parrots in that they simply recite the causal knowledge embedded in the data, right? So basically, they just provide you some causal knowledge that is already embedded in the data, because apparently these problems are the same. But when we mention these farmer, sheep, cabbage, and wolf, basically the LLM detect an example that is overrepresented in the training data. So it's not able to reason in the correct way about this specific problem. So that's interesting. That's another point to understand if LLMs are able to reason. And I would like to put the execution aside for now, because I would like to make more reflection to understand the role of LLMs in execution. So we understood the capabilities of LLMs, or the non-capabilities of LLMs, in try to address some specific tasks in terms of discover, reasoning, and planning. So now in the second part of this presentation, I would like to show you some very interesting and very recent examples that are able to show us how we can reduce the gap potentially between the human cognition and the LLMs by using graph technologies. Graph technologies, as I mentioned at the beginning of this presentation, in all their forms, right? Including, for instance, ontologies and knowledge bases, including graph algorithms, including graph machine learning, such as graph neural network architectures. So I would like to start with the first one, which where the paper is entitled Reasoning on Graphs. And in this paper, the authors clarifies that most of the current methods that adopt LLMs and knowledge graphs, they use this combination in two different ways. On the one hand, we have the semantic parsing. So basically, in this case, the LLM is used to convert questions, natural language questions, into logical queries to be executed on top of the knowledge graph. And the other approach that is usually adopted is called, and it's actually right now very well known, retrieval augmented generation, whose goal is to, in this specific case, retrieve knowledge graph triples and provide these triples as knowledge context to obtain the final answer from the LLM. Actually, these true standardized or well-defined approaches present some issues, right? Because in most of the cases, the generated logical queries can be often non-executable or do not provide any answer when they are run on top of the knowledge graph due to some mistakes in terms of syntactics or in terms of semantics information. And on the other side, the RAG methods often overlook the importance of factual knowledge for the reasoning task. So the authors in this case propose an approach that first of all consider a planning optimization phase that distills the knowledge from the knowledge graph to produce faithful plans in the form of relation paths. And the second key step is a retrieval reasoning phase, where the LLMs are enabled by the retrieved paths to conduct faithful reasoning and generate more interpretable results. So here you have just a high-level view of the framework that they have developed. Basically, given a question, the prompt start to generate several relations. These relations are then grounded by the knowledge graphs as a plans. So the next step is to retrieve the reasoning paths from the knowledge graph and then use the reasoning paths to generate more interpretable explanation from the large language model. I think that this example that they mention in the paper clarify all these points, right? So basically, they provide this example in order to compare the lack of knowledge that characterize ChatGPT combined with the chain of thoughts, which is a method to define step by step the reasoning of the LLM within the prompt. And this approach is compared to the interpretable prediction of the ROG approach, which stands for reasoning on graphs. So the question is, what type of government is used in the country with Northern District? And the answer is a parliamentary system. So if we analyze the answer from ChatGPT combined with this chain of thought, basically the answer is to determine what type of government is used in a country, we need more specific information because this Northern District does not match any known country by the large language model. So the large language model asks to provide additional details to clarify the specific country the user is referring to, right? While in the case of the ROG approach, it tried to detect the reasoning paths from a knowledge graph, and the system is able to discover that another district actually it's a local administrative division of the Israel country, right? Whose government form is parliamentary system. So when the LLM is able to access to this reasoning path, is able to provide a very detailed answer because it states that the type of government using the country with the Northern District is a parliamentary system. It is able to provide explanation, and these explanations are provided in the form of the retrieved reasoning paths. And then he condensed his explanation, saying that by following the reasoning paths provided, we can conclude that the country with the Northern District, which is Israel, uses a parliamentary system of government, right? So this is a way in which we can incorporate knowledge graphs and the reasoning paths, including in a knowledge graph, in order to provide more detail and potentially interpretable and faithful responses. Then we have another interesting approach that is discussed in this paper entitled GNN RAG, Graph Neural Retrieval for Large Language Model Reasoning. Considering some aspects that we already discussed for the previous example, the challenge of using knowledge graph to ground the answers from the LLMs are related to the fact that usually the largest and the most important knowledge graphs include millions of facts, right? But only a small portion of this structure, so basically only a small portion of this full knowledge actually includes useful details for answering the query. The remaining part of the knowledge graph usually includes irrelevant information that sometimes may actually confuse the LLMs during the answer generation. So basically, the researchers and the authors of this paper provide a solution that has a first step leverage a graph neural network to reason over a dense knowledge graph portion, so that reasons on a subgraph, in order to retrieve potential answer candidates for the question. Then the system applies a shortest path algorithm that extracts the reasoning paths connecting the question entities and the answer candidates detected by the GNN. And then the extracted paths that are the results of the shortest path algorithm are manipulated and verbalized by the LLM for the response generation. I would like just to recap the key idea of graph neural networks because they are a quite complex concept. But basically, the graph neural networks are a set of deep learning techniques that can be applied to graphs to perform some specific tasks, including, for instance, node classification. For instance, when we want to label, I don't know, collection of papers with their topic, and these papers are connected by the citation networks, right, in the universe, or they can be leveraged for performing link prediction, so understanding if a link exists between two different nodes in the graph. And in this specific case, in this specific approach, the knowledge graphs are trained for node classification, and the label are the answer is correct or the answer is not correct. So basically, the authors prepare a training question-answer pair dataset, and then they train a graph neural network in order to, learn on these datasets. So during the inference phase, the nodes with the highest probability are selected as candidate answers, and then with the shortest path that we mentioned before, we're creating these connections between the question entities and the candidate answers. So I would like to clarify this with an example. In this case, to respond to this question, which language do Jamaican people speak? Basically, the graph neural networks detect the possible candidates, which are English, Jamaican English, French, Caribbean. Then the shortest path algorithm tries to identify the connection between here, the Jamaican entity, and these potential candidates, and it is able to retrieve these specific paths, right? And according to the relationship within this path, where official language and language spoken are potentially the best options for answering the query, the LLMs use these specific paths in order to provide these results. I would like to show you another example, which is relevant because it characterizes multiple hopes in the knowledge graph. So the question in this case is, in which state did fictional character Guilfoyle live? And in this case, a traditional method that exploits knowledge graphs and RAG provides as a result Toronto. But when we leverage and exploit a GNN-based RAG, the result is Ontario, because the system is able to connect and perform multiple ops in the knowledge graphs, as you can see from this specific list of relationships. And the last paper that I would like to mention, in my opinion, it's one of the most interesting one, because in this case, researchers from Ohio State University and Stanford developed a novel retrieval framework, which is inspired by the hippocampal indexing theory of human long-term memory. And according to this theory, the long-term memory in the brain actually tend to accomplish two goals, right? On the one hand, the pattern separation, which ensures that the representation of distinct perceptual experience are kept unique, are kept separated, and then pattern completions, which actually enables the retrieval of complete memories by combining these partial and well-separated stimuli. And to perform and to reach and to model, right, this behavior, they created a solution in which basically they applied the neocortex ability to process the perceptual input, and concretely they use an LLMs to transform a corpus into a schemaless knowledge graph. So compared to the previous example, here we have a knowledge graph created on the fly. Then given a new query, this framework identifies the critical concepts and then use a personalized PageRank algorithm to identify, again, in this case, some relevant subgraphs in the knowledge graph. And then these subgraphs are leveraged to perform multi-hop reasoning and basically retrieve the response. So here you have a difference, right, of the current RAG approach, the human memory, and the HippoRAG approach that try to map the behavior of the traditional human memory. So in the above examples, we want to find a Stanford professor that does Alzheimer research. And actually, we would like to combine different text chunks that potentially describing thousands of Stanford professors and thousands of Alzheimer researchers. Since the RAG method encompass and encode just passages in isolation, basically that they would struggle to identify this information because we have separate chunks that we should process. In contrast, most people that are familiar with the professor would remember him quickly due to their brain associative memory capabilities, right? So inspired by their mechanism, they want to, the authors of these papers try to leverage LLMs to build a graph to identify this graph of these associations within the graph and tackle the knowledge integration task. So here you have much more details, but I would like to discuss and see with you how effective this approach is, right? Because if we see these three different questions, for instance, the first question, with the first question, we want to find a book published in 2012 by an English author who won a specific award. And we have seen that actually the other retrieval approaches that are based on the LLMs actually failed in these results, right? Because, for instance, the Colbert V2 approaches just focuses on awards and prizes. The IRCOT actually detect as a first result, Kate Atkinson, which actually won this prize, but in 1995, not in 2012. So this is a way in which this approach is able to overcome other more traditional approaches. And here we have other examples, right, of questions that require multi-hop steps in the knowledge graphs. Here we have which war film based on a non-fiction book was directed by someone famous in the science fiction and crime genres. And you can see that in this case, the system, the HyperRAG system was able to detect a very the right result for this very complex question at the third place, while the others are not able to do the same. And this type of approach can have an impact also in drug, right, in drug discovery. So for instance, what drug is used to treat chronic lymphocytic leukemia by interacting with this specific gene, right? And again, the system HippoRAG is able to detect the right answer, while the others are not able to do that by leveraging these multi-hop actions within the knowledge graphs. So when I asked ChatGPT to read these slides and to understand which is the role of graph technologies for LLMs, it says that graph technologies are able to improve and enhance LLM's ability to reason and plan by leveraging structured knowledge. And moreover, they enable more effective interpretable problem-solving capabilities. So in this case, ChatGPT, I think that was able to take the essence of the role of graph technologies for these specific problems. So I would like to conclude with some final thoughts and actually quotes related to the gap, to reduction of the gap between LLMs and human intelligence. And the opinion of Jan LeCun, again, it's very sharp. So basically, if you are a student or an academic researcher and want to make progress towards human level AI, do not work on LLMs, right? Because LLMs are an off-ramp. Because the only way you could possibly contribute in this field is to analyze existing LLMs and showing their power and limitations. But it's more fun, according to his opinion, and impactful to come up with new ideas and new architectures that potentially can comprehend also graph-based technologies in order to show that they might work. And I would like to conclude with these statements from Francois Cholet, which is a deep learning developer at Google and creator of one of the most important framework in deep learning, which is Keras, that says that if intelligence is the ability to deal with what you weren't prepared for, then the modern AI strategy, as we have seen until now, is to prepare for everything. So you never need intelligence. This is, of course, a terrible strategy because it is impossible to prepare for everything. So the problem isn't just scale. The problem is the fact that the real world isn't sampled from a static distribution. It's ever changing and ever novel. So if we want to apply our last step, our last task, which is execution, definitely we have to rely on human cognition to solve these real world problems that are always new and that are continuously changing. So thank you very much for your attention. And I don't know, Joachim, if we have time for questions or
Oh,
comments from the audience.
yeah. So I would advise the audience to contact Giuseppe directly through LinkedIn. He's placed his information here. You can also look up his Medium. His knowledge graph supplied is going to launch soon, right? That's
Yeah. I will launch soon. I think in autumn, let's say soon.
And one thing I would like to just say as a takeaway for myself is that I enjoy listening to Giuseppe because he's not just a computer scientist, he's also a poet. And the way that he describes and makes the point that machines can't think, and anybody that says that machines can think is kind of just stating nonsense. We are trying to emulate the function of biological mechanisms, but we still have a long ways to go because we don't even understand how the brain works. How can we try to mirror that in a simple chatbot? So
Yeah,
thank
yeah,
you.
definitely. Thank you very much, Joaquin.
Tune in for the next one. It's gonna go live in about 7 minutes. So bye.
Bye.